Good morning. Today we're going to start looking into Unit 12, which is talking about probability. And this is kind of a fun unit. It's using some of the skills that we've learned before, but it's also going to be exploring a different side of math, and that would be the statistics side. So let's dive right in and get started. First, let's do a little bit of review. So we practiced this earlier in the semester, where we practiced writing fractions as decimals and then percents. It says round to the nearest tenth of a percent if necessary. So to write a fraction as a decimal, we have to divide 31 divided by 50. So you can actually do that in your calculator. You can do 31 divided by 50. When you do that, you should get 0.62. So this would be the decimal part. And then to change from a decimal to a percent, we move the decimal 2 places to the right. So that would give us, if we move, let me change my color here. If we go 1, 2, that would give us 62%. Now, remember, you don't have to put the decimal if there's no number that comes after it. You can just write it as 62. You could write that as 62.0 if you wanted, but that's not necessary. All right, so for this one, we are going to do 11 divided by 40. When we put this in the calculator, we should get 0.275. Then we need to change that to a decimal. So we're going to move the decimal point, to a percent. Move the decimal 2 places to the right, and we would get 27.5%. This is all going to be useful for what we're doing today because a lot of our probability is going to be written between fractions and decimals and percents, and we're going to have to look at how to best write the answer. So some key terms we need to know are outcome. The outcome is the result of an action, and this doesn't just apply to today's lesson. Outcome could be what happens when you study for a test. The outcome of that. What happens when you kick a soccer ball? What's the outcome or the result of that action? An event is the outcome or a group of outcomes. And we'll talk a little bit more about that, but it's basically taking all of the possible outcomes and putting it into an event. And it says if all the outcomes are equally likely, then we can use a formula to find the theoretical probability. And again, we'll talk about that in a minute. So theoretical probability, we write it like this. We read this as P of event. When we read that out loud, we don't say P parenthesis event, we say P of event. And it's saying the probability of this event happening is equal to the number of favorable outcomes over the total number of possible outcomes. And again, we'll look at that and what that means. So suppose you roll a 6-sided die. What is the probability of rolling an even number? Express the probability as a fraction, a decimal, and a percent. Well, a 6-sided die would be one of these possible outcomes where every outcome is equally likely. I am equally likely to get a 1, a 2, a 3, a 4, a 5, and a 6. No one side is more likely to happen than the other. So they want to know what's the probability of rolling an even number. So my even numbers here are 2, 4, and 6. So I'm going to say I have my possible outcomes are 2, 4, and 6. That would be what we would call the favorable outcomes because it satisfies what the question is asking, rolling an even number. And then we divide that by the total number of possible outcomes. Oops. So this here is all of the possible outcomes. 1, 2, 3, 4, 5, 6. So there are 3 outcomes that satisfy what they're asking. And there are a total of 6 possible outcomes. So here's our probability expressed as a fraction, but let's put that into lowest terms. 3 over 6, I can divide both of those by 3, and I'd get 1/2. So there's the fraction. As a decimal, if I do 1 divided by 2, I get 0.5. And then as a percent, if I move that decimal 2 places to the right, remember I have to think about 1, 2, and so I have to fill in a 0 in this place. It's not 5%, it's 50%. So I did fraction, decimal, and percent. There we go. So then it says, what is the probability of rolling a number divisible by 3? So I'm going to write out my list of numbers again. And I'm going to look at which ones satisfy what they're asking. Numbers divisible by 3. Well, 3 is divisible by 3. I can do 3 divided by 3 and get 1. 6 is divisible by 3. I'd get 2. And it looks like that's it. So I have 2 favorable outcomes out of the total of 6 possible outcomes. So let's simplify that fraction. That would give us 1/3. Now we're going to write it as a decimal, and that would be 0.333 repeating. I'm going to put that bar over the 3 to show that it goes on and on forever. And then my percent would be 33.3%. If you want to put the bar over this, that would be fine. However, you could also just write it like this, and that would also be acceptable. Same thing with the decimal. If you don't want to include the bar, that's okay for now. But in that case, you do need to include enough numbers. If you just write 0.3, that is not sufficient. When it's a repeating number like that, I would say you need at least 3, maybe 4 numbers to make it as accurate as possible. So, all probabilities range from 0 to 1. You can see over here that we had a probability of 0.5, 0.333 repeating. We never had anything less than 0 or greater than 1. 0 represents an impossible event, something that is never going to happen. And numbers that are closer to 0 are less likely to occur. 1 represents a certain event, something that is for sure going to happen. And the closer to 1 a number is, the more likely it is to occur. So you can think about it like a number line. Well, actually, it's not even got arrows on the end. You could just say, here's 0, never going to happen. 1, for sure going to happen. Numbers that are down here are less likely to happen. Numbers up here are more likely to happen. So Adam flipped a coin 4 times. Find the probabilities. What is the probability of flipping 3 heads? Well, he flipped the coin 4 times. So flipping 3 heads, that would mean that 3 out of the 4 times he flipped heads. So let's change that to a decimal. 0.75. If we look back at our number line, that's probably about here. So that's in the more category. It's pretty likely to get 3 out of 4 times flipping heads. What about flipping the coin 4 times and getting 5 heads? Well, if I put that as a fraction, that's telling me 5 out of 4, which is over 1. So this is actually impossible. We can't have a value that's less than 0 or greater than 1. Anne picks one of the shapes at random from the right. Find the following probabilities. What's the probability of picking 2 triangles? Well, let's start by figuring out how many shapes there are. We've got 1, 2, 3, 4 triangles, and then 1, 2, 3 circles. So we've got 7 shapes total. So picking, we're talking about putting all of these shapes in a bag, shaking it up, and randomly drawing 2 out. So the probability of getting 2 triangles would be 2 out of 7. When I put this in the calculator, it's going to give me a long decimal, and I don't want to write every single number, so I'm going to round it to 3. which should give us about 0.285. And so this would be our probability. We usually express probability as a decimal. Sometimes percents will come into play, but usually we're going to use decimals because we want to use that scale of 0 to 1. So what's the probability of picking 3 circles? Now, it might seem like, oh, there's 3, so you're guaranteed. However, we have to think about it with all the shapes together. So 3 out of 7. So here, when I put this one in the calculator, thinking about rounding, it should be something like 0.429 instead of 428. So this is going to be our answer. So we're more likely to get 3 circles out of all of this than to get 2 triangles. So complements. This is not like when you tell your friend that you like their shirt. This is saying that the complement of an event is the collection of outcomes that is not contained in the event. So to find the complement, we're saying the probability of something happening and the probability of that thing not happening is equal to 1. Because let's say it's heads. So the probability of flipping heads and the probability of flipping a coin and not getting heads has to equal 1, because when I flip a coin, I either get heads or I don't get heads. It's one or the other. And so that's guaranteed to happen, and that's why it equals 1. So to find the complement, we have to take 1 minus the event, the probability of the event happening. So you roll a 6-sided die again. What are the probabilities? What's the probability of not getting 6? Well, there's 2 ways to think about it. So the first way is to say the probability of not getting a 6 is getting 1, 2, 3, 4, or 5, which would be 5 out of 6. Putting that in a calculator, we would get 0.833 repeating. Now, another way to think, and then that's the probability of not getting 6. The other way to think about it is to find the complement. So to find the complement, we would say the probability of not getting 6 is equal to 1 minus the probability of getting a 6. Well, the probability of getting a 6 is 1 out of 6. Which equals 166 repeating. So then if I do 1 minus 0.166, I'll get 0.833. So it gives us 2 different ways to look at the same problem. I'm going to use this second method for this next problem. The probability of not getting a 1, 2, 3, or 4 would mean that it's equal to 1 minus the probability of getting a 5 or a 6. The probability of getting a 5 or a 6 is going to be 2 out of 6, or 1/3, or 0.333. So 1 minus 0.333 repeating is 0.666 repeating. And this would be our probability. All right, so odds are something a little bit different. The probability ratios compare favorable outcomes and total outcomes. And we can write ratios called odds. Odds compare favorable outcomes and unfavorable outcomes. Odds in favor would be the ratio of the number of favorable outcomes to the number of unfavorable outcomes. And odds against would be the number of unfavorable outcomes to the number of favorable outcomes. So the following shapes were in a bowl. Find the odds that a shape chosen at random is a quadrilateral. I've got 1, 2, 3 quadrilaterals. So I've got 3, and it's odds in favor would be 3, 2, 3, 2, 3. Because there are then 3 unfavorable outcomes. We have 3 that match the criteria and 3 that don't. So our odds would be 3 to 3. So try this one and then check your answer. Your odds here would be 4 to 2 because there are 4 that are not triangles.